Hello, this is Ahmed Abulkhair from DataValley Technologies, and today we'll talk about ensemble learning. In some complex problems in data science, we find that the performance of our machine learning algorithm is very poor, even after spending some time understanding the problem and performing some feature engineering. At that point, we realize that combining several machine learning algorithms may come to the rescue. Ensemble learning is a technique that creates multiple models and then combines them to produce improved results. As a consequence, it supposedly produces more accurate solutions than a single model. The companion graph simplifies this concept a lot. Several models are being trained on the same dataset and then combined for hopefully better results. The interesting part about ensemble learning methods is that could be applied to regression and classification as well. For regression problems, you can create multiple regressors to address the same problem, such as linear, polynomial, and multiple regression models in an ensemble learning system. For classification, the same idea can be used for creating an ensemble learning system with models that can be diversified between logistic regression, decision tree, KNNs, SVMs, etc. In general, there are two main steps in ensemble learning. The first one requires building multiple machine learning models from the same or different algorithm, and they are called Bayes models. Then, the final and overall prediction that is being performed based on Bayes models. The question now is, what are the different approaches in applying ensemble learning? Well, there are four main techniques in applying ensemble learning: voting and averaging, stacking, bootstrap aggregation or bagging for short, and boosting. And in the next few slides, we will go through the idea of each type. Speaking about voting and averaging, you may have guessed now that voting is used in classification and averaging is suitable to be used in regression, and we will reveal the mechanics of each in the next slides. As this graph depicts, when handling a classification problem using the voting ensemble technique, we build an odd number of classifiers. Then we take the class that has the majority votes to be the final prediction. Here we have 3 cats versus 2 dogs, so the final prediction is cat. Unlike voting, when using averaging, we can use whatever number we want of regressors, then average the outputs to get our final prediction. In this graph, for example, our final prediction is 4.58. Stacking, or also known as a stack generalization, the basic idea of it is to train machine learning algorithms with the training dataset, then generate a new dataset out of their predictions. This new dataset is used as input for a combiner or final machine learning algorithm. As this graph shows, we have some training dataset, then we train multiple machine learning algorithms which are denoted in D1, D2 to DL. Then we use all these predictions to get a new dataset afterwards. We train a new combiner or final machine learning algorithm upon these predictions. In Bootstrap Aggregation, or bagging for short, at first we create multiple machine learning models. These models are trained with n random observations of m samples in the original dataset. Then we aggregate the results of these learners using voting or averaging depending on the problem itself. For example, random forest and extra trees are examples of bagging techniques. We can see from this graph that the second step when building bagging ensemble learning system is pretty similar to the voting and averaging techniques illustrated earlier. The graph to the left, here we have a regression problem. We have trained multiple regressors, then we average the final result and we got 4.58. The graph on the right, we have trained multiple classification models, then we have the majority vote, that is 3 cats versus 2 dogs, so the final prediction is cat. Boosting is used to describe a family of algorithms that can convert weak models to strong ones. And by the way, it's a very powerful technique in handling some complex problems in data science. This could be done by incrementally building and training models, and each model with the same training dataset, with the weights of instances that are adjusted according to the error of the last prediction. So in boosting, we are building machine learning algorithms sequentially. The last model will be trained on the last prediction of the previous model. And some models that are adopting these techniques are AdaBoost, XGBoost, also KataBoost, and LightGBM as well. And they are very powerful machine learning algorithms. So that's all for today. See you in the next tutorial. Thank you.